material we use is our primary supplier is Torre. These are, this is the highest quality supplier in the world, the largest maker of carbon fiber materials. These guys produce materials that are used in Boeing airplanes and satellite structures, etc., in aerospace. They've got the quality level that we need to make our shafts the best they can be. Triax is a material that's a woven fabric of carbon fiber materials, and it's actually woven in 3 directions. So what you might be used to in like a shirt that's woven in 2 directions, imagine a machine that weaves something in 3 directions. So we're looking at, this direction, and then one more like that. It's a pretty complex piece of equipment. That kind of material is exclusive to us. We use it in our speeder line. It started in speeder, and it's been used in some other products. We've got examples here of other cool materials, such as this spread toe fabric here from, it's called Textreme. We use that in our blur shaft. That's a highly advanced material because in other woven materials, they'll just be fiber bundles. They're relatively small, but they're still bundles, which means they're like yarn. They're going to be round in circumference, and then you're going to weave them. So you get a lot of over and unders, and there's some inefficiency in that. So what these guys do is they'll take that fiber bundle and they'll spread it first, flat. So now it's lighter because it's spread out, and then they weave it after it's been spread. So that's why it's called the spread toe woven fabric. And what you get out of that is lighter weight, less crimping of the fibers going up and down. So when you pull on it, it's super stiff. Extra stiffness, extra, a lot of feel in that material, and lightweight fabrics. Some of the lightest weight carbon fabrics are going to be coming from spread toes. The computer will print out a design sheet. The design sheet will tell us how to make that shaft and what we expect, how we expect it to behave when we test it. So we relatively know how this shaft will behave before we even build it. In terms of what we design, we're designing for things like the overall weight balance, location, how stiff things are in multiple spots, the twist of the shaft, all that stuff is your juggler. This is a machine that basically has a sellotape that's applied on at tension, and it's basically squeezing the air out of the shaft. So a pneumatic machine like this can yank the shaft off the tool, and at that point we process it by doing the shaft cutting, removing that tape, and then doing all the grinding that we need to get the finish that we want. We really don't want to, we don't want to damage the shaft. Sanding is relatively damaging the shaft, so we do a really light sand, no more than necessary. We've heard of some companies that might sand the flex. That's ridiculous to us. So every shaft is designed so that when it goes through this process and we remove the minimum amount that we need to, that shaft is in the specification we want, ready to go for paint. Flex equipment, and I can give you a quick demo of how we flex shafts. Buttons and flex, and there's a clamp here that will clamp the butt end of the shaft. And when I push this this button, it'll clamp, and then over here a finger will come down and it'll zero out deflection. It'll apply a known load, and then what it's doing is telling us how far it's deflecting. Okay? And this is really what we were calculating in our shaft code. We're actually able to estimate or predict that deflection amount. That deflection amount correlates to what we think has the type of performance for specific swing types or swing speeds.